Hello and welcome back. In this video, we are going to talk about the forces, the effect of forces, how a force can change the shape and size and speed and direction of the object. We will also sketch, plot and interpret the load extension graphs. We will also determine the resultant of two or more forces which are acting along the straight line, and we'll see how this resultant force can change the speed and direction of the object. We will also talk about the Hooke's law and the term limit of proportionality. So without any delay, let's proceed with the video. So what is a force? A force is a push or a pull. The boy here is pushing the box, the boy here is pulling the box. The person is pushing the door, the person is pulling the door. So push is a force away from you and pull is the force towards you. So it is measured in newtons. The unit to measure force is Newton. It's a vector quantity. What are vector quantities? Which have both magnitude and direction. So let's say this boy is pushing the box with a force of 10 newtons towards the right. So 10 is the magnitude and towards the right is the direction, right? So it's a vector quantity. So what a force can do? A force can change the shape and size of the object. How? I have a ball, you compress it, you change the shape as well as the size. I have a rubber band, you stretch it, you change the shape and the size. I have a slinky, you stretch it, the shape and the size changes. Similarly, you can change the direction and the speed of an object. How? A ball, a ball is coming towards you, kick it in another direction. Direction is changed. It is coming very slowly towards you. Kick it with a more force. Its speed changes. So I want you people to give at least two examples of how a force can change the shape, size, direction and speed of an object in the comment section below. Now talking about the load extension graphs. So to understand how the force, load means the force you are attaching to the spring, is related to the extension in the spring. So let's do a simple experiment. We will take a spring and attach it to the stand or the clamp in a vertical position. So I have taken a spring and attached it to this stand in a vertical position. Then I will measure the original length of the spring. Let's say this is L0, and make sure that you always take the length of the coiled part of the spring. Only the length of the coiled part of the string. Do not take the length of the hook or anything else, just the coiled part. Then we will add a weight to the bottom of the spring and measure the new length. Now we will keep on attaching the weight. Obviously when you attach some weight, let's say you attach 50 gram first, then you attach next time 100 grams, next time 150 grams, next time 200 grams and 250 grams and so on. Let's take 5 readings, right? So every time you hang the load over here, obviously this spring, this is the original length, it is going to stretch a little more. Then you add 100, it will stretch a little more, it will stretch a little more. And obviously when you remove this load, it will go back to its original length, which is still here, right? So we will keep on repeating this step 3 for different weights, as I said, 50, 100, 150 and so on. And then we will plot a graph to see how the force and the displacement of the spring from its original length, that is the extension, related. Then we will analyze the data to determine the relationship between the two. The two means the force, the means the load, the force and the extension. And obviously we have to repeat this experiment multiple times to make sure that the results we get are consistent and accurate. Accuracy is very important in our results. So let's see. Let's say I have have the readings, and when I plot the graph, I take force over this side, force or the load, and I'm taking it to be in newtons, and extension. Do not forget to mention the units on your graph. Extension, let's say it is in centimeters on this side. So when you plot a graph, you see that the graph comes out to be a straight line. You get a linear graph. When you take the readings of the the extension and the load, you find that when you plot the graph of extension and the force, you get a straight line. That means the force you are applying on the spring is directly proportional to the extension. Extension is denoted by the letter X. The force and extension are directly proportional to each other. What does it mean? That means if you increase the force, the extension in the spring increases in the same proportion.
For example, if you have attached a mass of 50 gram, the extension was, let's say, 2 centimeter. Next time you increase the load to 100 grams, let's say this time the extension become 4 centimeter. 150 grams, 6 centimeter, and so on. So force and extension are proportional to each other. So if I remove the proportionality sign, I get small k as a constant x, where k is the spring constant. So what is a spring constant? Spring constant basically decides the stiffness in the spring. More the value of k, stiffer is the spring. Less the value of k, looser is the spring. So F is equals to kx, or I can say k is equals to F by x. This is also known as Hooke's law. This is also known as Hooke's law. So it's clearly visible that force and extension are proportional to each other. Proportional means whenever you plot a graph between the two, you will get a straight line. And if you remove the load, the spring will go back to its original length. But do you think that every time you are hanging the load and removing the load, the spring will keep on going back to its original length? No. Let's say I've attached a weight of, let's say, 500 grams. Okay, now the spring is going back to its original shape. 1000 grams, 1 kg. But a point will come that when you remove the weight or you remove the force, but the spring doesn't go back to its original shape. Why? Because at that point, the spring gets deformed and you no longer gets a straight line. You will not, now you will not get a straight line. Your graph will be now curved. Why? Because this time when you hang the load, the spring will not go back to its original shape because it is deformed. And this point is known as limit of proportionality. This is the limit after which the force and extension are no longer proportional to each other. I hope it is clear. Now talking about the resultant of forces, we will only talk about the forces which are acting in the straight line. I have a car, two forces are acting on it, 20 Newton towards the left, 40 Newtons towards the right. What is the resultant force on the car? Because these two forces are acting in the opposite directions, I will subtract them. 40 minus 20, which gives me 20 Newton towards the right. Why right? Because more force was towards the right. So this is my net force or my resultant force. This is my resultant force. Right? What if the two forces were acting in the same direction, 40 Newton and 20 Newton? 40 Newton and 20 Newton in the same direction. So the net force will be 40 plus 20, which is 60 Newtons towards the right. Why? Because both the forces are acting in the same direction. Right? The size of the arrow actually determines the magnitude of the force. More the magnitude, bigger is the arrow. Here we have a parachute falling. A person is falling with a parachute. The weight of the person acting downwards, let's say 400 newtons, and the weight of the parachute or the air resistance acting upwards, this is also 400 newtons. So what do you think if the resultant force? I can say that the resultant force is equals to 400 minus 400. Why? Because the two forces are in opposite direction. So I will subtract, I will get 0 newton. 0 newton, what does it mean? If the force acting on the object is 0 newtons, what will happen? Will the person in the parachute stay in the air? No. What will happen then? The person along with the parachute will keep on falling at a constant velocity. A very important point to note from the point of view of exams. If the resultant force acting on the object is 0, the object either remains at rest or keeps on moving with a constant velocity. Why? Because there is no resultant force. If there is no resultant force and the object is at rest, how will it move? It cannot move. And if it was moving with certain velocity, it will keep on moving with the same velocity because there is no external resultant force acting on it.
So this point is very important, especially from the point of view of IGCSE exams. This resultant force, if this resultant force is zero, then this is the case. If there is certain resultant force acting on an object, it will move in the particular direction, right? As we have seen in this car's case. We have an aeroplane, so there are various forces acting on an aeroplane. We have its weight acting downwards, we have the lift force, we have the air resistance force. So if all the forces are balanced, if the right and the left forces are balanced, the upward and the downward forces are balanced, then this aeroplane will keep on moving with a constant velocity in a certain direction, right? So the resultant force can therefore change the speed and direction of an object, right? And if this resultant force is zero, the object will will remain at rest or will keep on moving at a constant velocity. So I hope this is clear. If you have understood the concept, do like, share and subscribe to the channel. See you in the next video. Thank you.